Hello everyone, welcome to MEMONEET. This is Aprajita, your chemistry SME, and I welcome you all today. So how are you all doing? I hope your preparation is going well. So students, in this video lecture, we are going to study about the molecular orbital theory, as you can say. Now, from which chapter it is there? So it is from the chemical bonding chapter, okay? So here you can say that the chapter that we have, chemical bonding and molecular structure. So this topic, it's actually an important part of that chapter. Why I am saying this? Because a lot of questions are asked in NEET examination from this particular topic, and I think you people might be having some doubts in this particular topic, because here we have to make energy level diagrams which are a little bit tricky to understand. So that's why I have taken this complete topic today, where we will be discussing it in detail. Okay. So if you have anything else that you want me to explain like this only, I told you to comment in the comment section that if you are not able to understand any topic, you want a separate video on that. So you can comment below in the comment section and I'll make a separate video on that particular topic like I am doing today. So if you are having any particular topics from the chapter we have covered, so you can tell me and we will do it separately. Okay. So we will be starting with molecular orbital theory. So we will be mainly focusing on the practical applications, and stay till the end. Okay, watch the video till the end because I am going to discuss the PYQs of NEET also. So you will get an idea ki what kind of questions are asked from the molecular orbital theory and how you have to solve those questions. Okay, so we will be focusing on the practical application part more. So but before that, let us discuss the various postulates of this theory. Okay, so what are the postulates of this theory? Try to understand. So the electrons in a molecule are present in various molecular orbitals as the electrons of atoms are present in atomic orbitals. So when we studied hybridization, we saw the atomic orbitals ki electrons of the atoms are present in atomic orbitals. Similarly, if I am talking about a molecule, so the electrons in the molecule are present in the molecular orbitals. Okay. Now what happens is that the atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. So ये molecular orbital बनते कैसे हैं? By the combination of atomic orbitals of comparable energies and proper symmetry. Okay. And while an electron in the atomic orbital is influenced by one nucleus, so in an atom there will be one nucleus and electron will be under the influence of that one nucleus only, whereas in the molecular orbital it will be influenced by two or more nuclei. Okay, means depending upon how many atoms you are having, like if you are having two atoms, so the electrons will be under the influence of two nuclei and so on. Okay. So you can say ki atomic orbital is monocentric, means there is only one center, means one nucleus, whereas molecular orbital is polycentric. Poly means many. Okay, many centers, or you can say many nuclei. All right. Then if I talk about the number of molecular orbitals, so what are the number of molecular orbitals formed? So how many atomic orbitals are combining? So you can say कि the number of molecular orbital formed is equal to the number of atomic orbital combining. Okay, means if two atomic orbitals are combining, two molecular orbitals are formed. Now this is something important कि when two atomic orbitals combine, we get two molecular orbitals. One is called bonding molecular orbital, while the other one is called anti-bonding. So what are these? We will discuss in detail. Now bonding molecular orbital has lower energy and greater stability. So you know always ki chemistry mein if we study, so lower energy corresponds to greater stability. Okay, so bonding molecular orbital has low energy and more stability than the anti-bonding molecular orbital. Okay, so for any atom, how do we tell the electron probability distribution? We tell it by atomic orbital, na? So similarly, the electron probability distribution around the group of nuclei in a molecule, कि एक molecule में कैसे electron distribution हुआ है, that is understood or given by the molecular orbital. Okay, that's the meaning. And how to fill the molecular orbitals? Just like we fill the atomic orbitals in accordance with Aufbau's principle, Pauli's exclusion principle and the Hund's rule. Okay, So these are the main postulates of molecular orbital theory. Now what do we mean by this thing, the bonding and anti-bonding molecular orbital? So try to understand, students, these are the wave function, okay, psi A and psi B. So these are the wave function corresponding to the atomic orbitals that we are having. So we are having two atoms, let's say two atomic orbitals, psi A and psi B. So the two molecular orbitals that are formed, so how they will be formed? Let's say I am having hydrogen atom only, let's say. So this is psi A and this is psi B. One electron each. Okay, let's not take electron as of now. So what we can do is we can just take the orbitals. So what will happen, students? Now these orbitals will combine. Now these wave functions, these are actually wave functions. So there can be addition of wave function. So whenever there is addition of wave function, we get a molecular orbital, okay, which we call as, or you can say it will be psi A plus psi B, and this we call as the bonding molecular orbital. Okay, bonding molecular orbital. And as I told you ki bonding molecular orbital has lower energy and greater stability than the anti-bonding. So this is the wave function for bonding molecular orbital. You can see that the waves have been added. Okay, so there is addition. Now whenever there is subtraction of the wave functions, so after subtraction what do we will be getting? So it will be psi A minus psi B, and it will be your anti-bonding molecular orbital. Okay, so how anti-bonding molecular orbital is formed? By the subtraction of the atomic orbital's wave function. Okay, yes, you can see here. So if I am taking it to be, let's say if it's hydrogen atom, okay, it's hydrogen atom. So two hydrogen atoms combine to form a molecule. So each one has one electron. So when, and you know that for hydrogen the electron lies in 1s orbital. Okay, 1s subshell mein it will be lying. So when this combine, we will be calling it as sigma. Okay, sigma bonding molecular orbital, and this is sigma star. So star represents anti-bonding. Sigma star means sigma anti-bonding molecular orbital. This is how we represent it. क्योंकि यहाँ पर sigma bond is formed. If pi bond is formed, we will be writing pi and pi anti-bonding. Okay. So this is how it is formed. So we'll put the two electrons here according to the Aufbau's principle. So electrons will occupy the lower energy one first. Okay, lower energy molecular orbital पहले वो occupy करेंगे. Then once it is filled, after that it will go to the anti-bonding molecular orbital. Okay. Alright, so this is how the molecular orbitals are formed. So you must understand the difference between bonding and anti-bonding molecular orbital. Okay. So let's say if we are taking some examples. If I am taking any two isolated hydrogen atoms like I told you. So what will happen after the addition? Okay, means how the bonding orbital will be formed. This will be the shape of the bonding orbital because it is formed by the addition. So this is your bonding molecular orbital sigma 1s. So this is sigma 1s bonding molecular orbital. Okay. But when it is subtracted, so anti-bonding mein you will be having node also. Node, now do you know what is node? Node is the region. We have studied it, okay, when we studied about quantum numbers, we have studied it. So it's a region of zero electron density. Ki at this position there will be no electron density, so that will be node. You can see here it because this is your anti-bonding molecular orbital. So you will say this is sigma star 1s, means sigma 1s anti-bonding molecular orbital. So this is for the s orbital, so they'll form sigma bond. Let's say if I am having p orbitals, okay, so how p will combine? Let's say if we are having two p orbitals, they should be of like same orientation, px px, py py, pz pz. So you see if they will be adding up, so you will be getting sigma 2p molecular orbital. Okay, so this is sigma 2p bonding molecular orbital, and in sigma anti-bonding you can see this is sigma 2p anti-bonding molecular orbital, and it is also having a node. You can see it is formed by the subtraction. All right, so this is the head-on overlap. No, If like sidewise overlap happens, so you will be getting pi. So this is pi, all right, just not sigma. So you can write pi 2p. So this is sidewise overlap. You know when sidewise overlap happen, all right. So what that would be? This is a pi electron cloud above and below the plane. Na? So this is pi 2p bonding molecular orbital, and similarly it will be pi anti-bonding 2p molecular orbital. All right. So usually we take the internuclear axis along z axis. So what happens is the pz orbitals, all right. So if I am talking about 2pz, so it will be forming sigma 2pz orbital, and the other ones, the pi 2px and 2py will form pi molecular orbital, pi 2px and pi 2py, and they'll be having same energy. So this is how the bonding and anti-bonding molecular orbitals are formed. This is not our concern. Now we need to look at the energy level diagram. So that is something important that we must know. So this is the energy level diagram for homonuclear. Try to understand these words. Homonuclear diatomic molecule. Homonuclear means same atoms are there, and it's a diatomic means having two atoms only. So for homonuclear, heteronuclear mein do atom alag alag honge. Here the atoms will be same. If it's hydrogen, so H2, okay, then He2, then Li2, Be2, boron 2, carbon 2, nitrogen. So it is up to nitrogen. Keep that in mind. We are talking about the up to nitrogen. This diagram is not valid for oxygen, fluorine and neon. I will tell you what is the difference. So keep that in mind. It is there exception likh lena. Oxygen, fluorine and neon. Of course neon doesn't exist, but here we are considering. So this diagram is not valid for that. Okay. So you know the atomic orbitals have the energy 1s, 2s, 2p, then so on. So how they will combine? They will combine in the same order only. Here you can see 1s will combine with 1s to form sigma 1s, then sigma star 1s. Bonding, then anti-bonding. After that 2s and 2s atomic orbital will combine to form sigma 2s and sigma star 2s. So this is the energy level that you have to remember. Sigma 1s, then energy sigma star 1s, okay, anti-bonding, then sigma 2s and then sigma star 2s. This is the level. After that, now what will happen for these atoms, hydrogen, helium, lithium, for up to nitrogen, now 2p orbital will combine. Okay, so 2p has 2px, 2py and 2pz. So I told you we are taking the internuclear axis along z axis. Okay, so z, this is we are considering z axis. So 2pz will form sigma bond. Okay, 2pz will form sigma bond, whereas 2px and 2py will form pi bond. That's what we are considering. Keep that in mind. So the energy of pi 2px and 2py will be same. So here you will be writing pi 2px equal to or like similar to pi 2py, means they'll have almost equal energy. Then sigma 2pz will come. Okay, after that anti-bonding orbitals, pi star means pi anti-bonding 2px, again same energy as pi anti-bonding 2py, and then sigma anti-bonding 2pz. So this is the order that you have to remember for these molecules. Okay, this is very important. This is the order. Please note, this is the general order we have. Now I will tell you what is it for the oxygen, fluorine and neon. But before that, try to write this order first. Okay. Now students, if I talk about the oxygen, fluorine and neon, so there is only one change that you have to keep in mind. Okay, so I'm writing this here. So for oxygen, fluorine and fluorine, and if neon is asked, okay, so sigma 1s, then sigma star 1s, this remains same, sigma 2s, sigma star 2s. Okay, there is no change in the s molecular orbital, but the change starts if I am talking about p. So as we are moving from left to right in the periodic table because of increased nuclear charge, see, you don't have to understand this, but I'm just telling you the difference, energy difference between 2s and 2p orbital increases as we are moving from left to right. Because of that, what happens is this sigma 2pz, it will come before the pi 2p x and pi 2py. This is the only change that will happen. Okay, and rest, the anti-bonding will remain same, pi star 2px, then pi star 2py, and sigma star 2p z. Okay, so this is the thing, keep in mind, only change is in the position of sigma 2p z orbital. It will come below pi 2px and pi 2py in the case of oxygen, fluorine and neon. This you have to remember. So please note down both these energy orders. Okay, so this is important. If you remember it, you can solve any kind of question. Okay, this is what we have to remember. All right. So now let's talk about various other factors that we can tell using the molecular orbital theory. The first is stability of molecules. Okay, so here what we do is, if let's say Nb is the number of electrons which are there in bonding orbitals and Na is the number of electrons which are there in the anti-bonding orbitals. So molecule will be stable if Nb greater than Na, means number of electrons in bonding molecular orbitals are more than number of electrons in anti-bonding orbital. Molecule will be unstable if Nb is less than Na. Okay, keep that in mind. If more number of electrons are in anti-bonding molecular orbital, the molecule will be unstable. Why it is happening? Because if more bonding orbitals are occupied, means bonding influence is stronger, and you know bonding molecular orbitals are stable, so that's why it will result in a stable molecule. But if more number of electrons are in anti-bonding molecular orbital, so anti-bonding influence will be stronger and the molecule would be unstable. Okay, so that is the thing, bond order. So if they are asking you about the stability of molecule, you have to use these two results. Then bond order is the one half the difference between the number of electron present in bonding and anti-bonding molecular orbital. So this is how you calculate bond order. Very, very important. This is the formula. Okay, so obviously what will happen, students, agar if the number of bonding orbitals are more, so the bond order hai, it will be positive, and if bond order is positive, the molecule will be stable. Okay, but if the anti-bonding electrons are more, the bond order would be negative, and we cannot have a negative bond order, because bond order means the number of bonds a molecule is having, whether it's having one bond, single bond, double or triple. Bond order can be zero also. Okay, bond order, if it is zero, means if the number of bonding and anti-bonding electrons are equal, the bond order will be zero, means the molecule does not exist. That we will see in the case of noble gases. The bond order of He2, Ne2 will be 0. Why 0? Because these are noble gases. They don't exist as molecules. They exist as monoatomic atoms only, right? Monoatomic molecules, you can say. Alright. So nature of bond, I told you, if the bond order is 1, so that means it's a single bond. Bond order is 2, it's a double bond. Bond order is 3, it's a triple bond. So bond order can be in a decimal also, keep that in mind. Alright, it can be 1.5, 2.5, like so on, 3.5 and so on. Okay. Now keep that in mind, students. Bond length. So bond length ko we will relate with the bond order. So bond length decreases as bond order increases. So you can say that bond length, keep that in mind, is inversely proportional to bond order. So if I am talking about the bond length of single, double and triple bond, so for bond order of triple bond is highest, so the bond length of triple bond will be the least, then double bond, and then single bond. Keep that in mind. This is something very important I am telling you. Okay. Next, another very important thing is magnetic nature. So when we are filling the electrons, so we need to see ki if all the molecular orbitals are doubly occupied, means all the electrons are paired. So if all the electrons are paired, the substance will be diamagnetic in nature. Okay. means it will be repelled by the magnetic field. But if the molecular orbitals are singly occupied, even if there is one unpaired electron, okay, unpaired electrons are present, so in that case the molecule will be paramagnetic. Okay, paramagnetic means it will be attracted by the molecular magnetic field. For example, we have oxygen. All right, so that is the thing, students. Now we will be seeing some examples. So this is what you have to remember. Now we will see the examples for different molecules. Let's start with hydrogen. So you know hydrogen atom has one electron, so another will also have one electron. So total electrons कितने हमें fill करने हैं? 2. And the electrons are present in 1s atomic orbital. So it will combine to form sigma 1s and sigma star 1s. So the configuration would be sigma 1s. Now both the electrons will go to sigma 1s only, क्योंकि unless the pairing happens, pairing करके ही हम next orbital में जाएंगे. All right. So that's what we will be following in this case. Okay. So Pauli's exclusion principle के accordance में, so it will be sigma 1s2. So this is how you are going to write the configuration for hydrogen molecule. It is sigma 1s2. Now calculate the bond order. Bond order क्या होगा? Half into number of bonding electrons. Bonding electrons कितने हैं? Means the electrons present in bonding molecular orbital 2 and anti-bonding में कोई नहीं है, 0. So it is 2 by 2, which is 1. So it means there will be a single bond between hydrogen in hydrogen molecule. If you want to talk about the magnetic nature, so of course paired electrons are there, so it's a diamagnetic molecule. Keep that in mind. Okay, so sometimes students, what happens is they ask you about H2 plus. Okay, like they will tell you कि H2 plus का bond order बताओ. What will be the bond order of H2 plus, or whether it is paramagnetic or diamagnetic. So nothing, don't worry, you know the molecular orbital diagram of H2. Okay, sigma 1s2. So H2 plus means just one electron has been removed from hydrogen. Okay, if I remove one electron from it, it becomes H2 plus. अब वो one electron कहाँ से जाएगा? It will go from sigma 1s only. So the configuration will be sigma 1s1. Okay, so sigma 1s1, तो bond order will be half into 1 minus 0. So bond order क्या आ जाएगा? 1 by 2, and it will be paramagnetic, because only one electron is there and that is unpaired. So H2 plus means one electron has been removed, and that will be removed from the highest energy जो occupied होगा, highest energy molecular orbital. Okay. So all these things I have discussed here in detail. Keep that in mind. Next, for He2. Now you know helium has atomic number 2, 2 electrons. So 2 plus 2 means 2 atoms से आएंगे. Okay. So total 4 electrons we have to fill. Again the configuration will be sigma. Now 2 electrons I have filled in sigma 1s. Now the other 2 electron will go to the anti-bonding molecular orbital. So the configuration for helium 2 will be sigma 1s2, sigma star 1s2. I'll be writing the number of electrons in the superscript. Bond order निकालेंगे. Half into bonding molecular orbital में 2 electrons, anti-bonding में भी 2. So it is coming out to be 0. Just now I have told you कि bond order 0 means that the molecule does not exist. Okay. But they can ask you for He2 plus, okay, helium 2 positive. So one electron will be removed. अब वो कहाँ से remove होगा? Highest energy वाले से, right? That you know. Okay. So the configuration will be sigma 1s2 and sigma star 1s1 now. So the bond order will be half into 2 minus 1. So that will be 1 by 2. Okay, this is how positive negative के लिए you have to do. Alright. Same goes for lithium 2. So again the configuration is sigma 1s2, sigma star 1s2. Now how many electrons for lithium? 2, total 6 electrons. So now the next 2 electrons will go to the sigma 2s2. Okay, sigma 2s2. So this is the configuration. And same, you can find out the bond order, half into how many electrons in bonding? 4, and anti-bonding में 2. So 2 by 2 it's 1. So bond order is 1 and it's also a diamagnetic molecule because all the electrons are paired. Okay. So that's why I'm discussing with you every example so that you can understand it in detail. Now comes is nitrogen, very important. You can do it for beryllium, boron. Okay, you can do that. We are discussing nitrogen now. So nitrogen में total you have to fill 14 electrons. Here now 2p orbital will come. And I have told you that up to nitrogen ये order follow होगा. Okay. So you can just simply write the order first. Sigma 1s, sigma star 1s, if you remember, sigma 2s, sigma star 2s. Okay. Then what comes? Pi 2px. Okay. Pi 2px, pi 2py. Then sigma 2pz comes. Then pi star 2px and pi star 2py and then sigma star 2pz. So this is the order. Now start filling the electrons. Okay. Start filling the electrons. How will you fill it? Just a minute. Yes. So 14 electrons I have to fill. 2 will go here. 2, 2, 2. 8 electrons done. यहाँ पे 2, 2 will come. 10 and 12 and then 14. So this will be the configuration up to sigma 2pz2. This is the configuration for nitrogen molecule. Now if I have to find the bond order, so half, अब calculate the number of electrons in bonding molecular orbital. कितने हैं? 2, 4, okay, 6, 8, 10. And anti-bonding में how many I am having? Only 4. Okay, sigma star 1s में, sigma star 2s में. So 10 minus 4, it's 6 by 2 and it's 3. So you know students that bond order is coming out to be 3 and you know there is a triple bond between the nitrogen atoms. Okay. And of course it's again diamagnetic. Why it's diamagnetic? Because all the electrons are paired. Okay. So I think nitrogen tak clear hai. All right. So this question was asked in your NEET examination also ki what is the energy level like energy order for the N2 molecule. So this thing was asked. If you remember it, you can do it easily. Okay. Around 8 to 10 marks you can get from here. Now comes is oxygen. Okay, they're very, very important. Oxygen. I told you there will be only one change. Again, same field, write the thing here like sigma 1s, then sigma star 1s, then sigma 2s, then write sigma star 2s. Now the change. Now sigma 2pz will come first. Okay, then pi 2px, pi 2py. All right, then pi star 2px and pi star 2py and then sigma star 2pz. Okay, now start filling up the electrons. 16 electrons, 2, 4, 6, 8, 10, 12, 14. Now students, very important thing that pi 2px and pi 2py have equal energy. So you have to fill 2 electrons. So you will not just go and write pi star 2px2. No, you will put 1 electron to both of them because they are of equal energy. And जब तक equal energy में at least एक electron नहीं जाएगा, the bond pairing will not start. Keep that in mind. Okay. So they will have 1 electron each. Now you can find out the bond order. Half into number of electrons in bonding. 2, 4, 6, 8, 10. And in anti-bonding 2, 4, 5, 6. Okay. So 4 by 2 which will be 2. Alright students. So students, bond order 2 means there is a double bond between the oxygen atoms, and one more very important thing that this is a paramagnetic molecule. Now why it is paramagnetic? As you can see in pi star antibonding orbitals means here you have 2 unpaired electrons. Okay, so don't just put 2 electrons in pi star 2px or pi star 2py. It will be 1 each because they are of equal energy and because of that oxygen is पैरामैग्नेटिक. तो स्टूडेंट्स you know कि ऑक्सीजन के लिए you get the question for like O2 positive, O2 positive, O2 minus, O2 2 minus. Okay, so that's what you need to do in this case and find the bond order and everything. All right, like if I do it, just a minute, like give me 1 minute. This is for fluorine. If I am talking about O2 plus, तो O2 plus में क्या होगा? One electron will be removed. So one electron will be removed from either 2px or 2py. Okay, so यहाँ से एक electron चला जाएगा. So bond order will be half into 10 minus 5. So 5 by 2, which is 2.5. Bond order will increase. If you are gaining one electron, okay, so if the one electron is gained, so in that case it will go to either of 2px or 2py. तो एक यहाँ पे 2 हो जाएगा, pi 2px2. Okay. So again in that case the number of anti-bonding electrons will increase 10 minus 7, so 3 by 2, it will be 1.5. O2 2 minus, अगर O2 2 minus होगा, so it will be pi 2px2, sorry pi star 2px2 and pi star 2py2. वहाँ पे electronic configuration पूरी हो जाएगी. 18 electrons होंगे, right? If 18 electrons are there, so again it will be 10 minus 8, so 2 upon 2, the bond order will be 1. So keep that in mind how to write the configuration for ions also. Nitrogen के case में hydrogen and for oxygen you get these type of questions. Oxygen के लिए तो ये तीन आपको आने ही चाहिए. Okay. Same goes with fluorine. You can see कि fluorine is just like oxygen. All right. So यहाँ पर 18 electrons are there again. So यहाँ देखो sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Again it's fluorine, तो pi 2p, sorry sigma 2pz2 पहले, then pi 2px and pi 2py, both will have 2 electrons, then pi star 2px2 and pi star 2py2. Okay, so bond order यहाँ पे 1 आ जाएगा. Try to calculate star. Okay. So pi star it will be there. So bond order will be half into number of electrons total कितने हैं? 10 minus 8. So this 1. Okay, so this is for fluorine. So I hope now you know how to fill the electrons for every molecule, like homonuclear diatomic molecules are there in your syllabus. So try to understand this, try to remember this order, and now I'll show you some of the PYQs that have been asked. So students, you can see here that this question was recently asked in your Neet 2024 examination. So this screenshot I have taken from our NTA PYQ book, okay, where you will be finding all the PYQs year wise. Okay, so it says, and topic wise also. So go to the chemical bonding and molecular structure chapter in the NTA PYQ book, and under the heading of molecular orbital theory you will find all the questions. So you will get to know कि molecular orbital theory से अभी तक every year at least 1 or 2 questions have been asked. Okay, so keep that in mind. So the question is very simple now, because we have discussed which of the following molecule is paramagnetic. So just now students, I have shown you for hydrogen, lithium. For carbon also you can do, like again 12 electrons will be there and it's diamagnetic. So all three of them are diamagnetic. But just now we have seen for oxygen, here you can see in the case of oxygen that there are two unpaired electrons. Okay, pi star 2px1 and pi star 2py1. So because of the presence of these unpaired electrons, the oxygen is paramagnetic. Now how can you answer this question? If you are able to write down the electronic configuration. Okay, so if you are able to do that, you can answer the question very easily. So the answer for this particular question would be oxygen, and you will get 4 marks. So easy, right? So just understand the two orders that I have given you up to nitrogen, and for oxygen, fluorine and neon. Rest everything will be done. Next question is the correct order of energies of molecular orbital of nitrogen. See, it was asked in NEET 2023. So every year you will get at least one question. So just now we have discussed कि for nitrogen we have 14 electrons. So let's start. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. And for nitrogen, pi 2px and pi 2py will come first. Pi 2px, pi 2py, then sigma 2p z. So if I am writing 2 electrons each here, so 2, 4, 6, 8, 10, 12 and 14. Tada, this is the electronic configuration for the molecular orbital or correct energies for molecular orbital of nitrogen. Now you can find out the right answer. So sigma 1s, sigma star 1s, then sigma 2s, sigma star 2s. So this is not right because here pi 2pz is coming first. Okay. So here also this is not right because pi sigma 2pz is coming after the anti-bonding. This is also wrong. This is also wrong. I think fourth one is correct. No. Here also sigma 2pz is coming first. This is wrong. So sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, sigma. So this is the order. So they have just asked the order, not the answer is going to be option D. But you must remember, instead of nitrogen they can give you any molecule. Okay, but for oxygen, fluorine and neon the order will be changed. Only one change, sigma 2pz will come first below like before pi 2px and pi 2py. Okay. So see, this is how the PYQs, very easy PYQs are there. So I think now the molecular orbital theory is clear. So if it is clear, I want your comments in the comment section. Okay, ki ma'am, yes, we are now able to understand the molecular orbital theory. So please do comment below. And yes, also comment ki if there is any other topic that you want me to cover now, because all these topics are very important if you are facing any difficulty in any particular topics. So do let me know through the comment section. Okay, and I hope this molecular orbital theory is clear. Just try to remember these two orders that I have given you. Okay, and then remember how to find out the bond order, which is important. They can give you question based on bond order and the paramagnetic behavior and diamagnetic behavior also. Okay, so that is again very important. So I hope students everything is clear now. All right, so I'll take your leave now. So please understand it carefully, solve all the PYQs. Okay, solve all the PYQs, and if there is any doubt, do let me know. Okay, and please do comment, like and share this video. Thank you so much.